Hey everyone, and welcome to a new video. Have you heard about humanoid robots? Of course you did. This year was the Automatica in Munich, and I was live there to see the latest achievements in robotics, sensorics, and artificial intelligence. In today's video, I want to give you a short summary of nearly all the topics that I have seen at Automatica. And I warn you, you want to see more afterward. And if you stay until the end of the video, I will also tell you something from behind the scenes. My name is Eric Schmidt. I'm a young scientist from Germany with profession in artificial intelligence, sensorics, and data analysis. Subscribe if you want to see more. Alright, I was one day at Automatica and there was so much included. Humanoid robots from several companies. Robot arms from small, medium-sized to huge. Different sensors like force sensors, ultra-fast sensors, distance, 3D sensors. There was image recognition, image segmentation, and so many more topics. In today's video, I want to give you a short summary about all the topics. And in the follow-up videos, I want to precisely go into these certain categories and tell you way more. So if you have wishes what I should cover additionally to what I present today, let me know in the comments. For everyone else, just subscribe to the channel. So let's get started. Let's start with humanoid robots and with the latest robot of Neue Robotics from Germany. It's for anyone. It is equipped with deep reinforcement learning and has a size of 1.80 meters, so a bit larger than an average human. With its 80 kilograms, it can lift up to 100 kilograms. But let's focus not only on this. Let's take a look on the skin. It's equipped with a special type of paint. It's a skin that can actually sense. So what do I actually mean by this? Let's take a look. When I take my hand and come close to the skin will react on my finger or on basically every object that is coming close to it. And this works even when I hover over the surface, so I don't even have to touch the paint that my finger will be recognized. Let's think this further. You can take any robot, spray this paint on top, and the robot becomes sensitive. It can feel your move, it can feel your touch, and it can react on it by, for example, stopping. This is great for safety purposes. Here you can see a humanoid robot which, similarly to Neura, has the size of a human with all the joints, arms and hands, and which can perform similar motions like a human. Let's directly continue with robot arms and robot hands. The eye-catcher in the startup arena was the Swiss robot of Beauftragung. Beauftragung made the design decision of building very lightweight but also very long robot arms, which helps the robot to reach far away objects, which is especially helpful in warehouses and similar situations. Also, hands are necessary for a robot. For example, the multi-sensoric hands from agile robots. And if you are more interested in soft robotics, you should check out Alonic, a startup that is specialized in building three-dimensional soft structures. Like for example these soft robot fingers which they produce with their super fast machines. If the robots are more used in the household as cleaning robots or something that interacts with humans, we call them service robots. They are designed to perform tasks which normally are done by a human or something non-industrial. For example, the service robot MIPA from Robotics. This one can clean up your house and cook food for you, for example with the Thermomix. Also the Swiss robot, which I showed you earlier, has actually a nice place for carrying heavy water bottles. What a service, isn't it? What we can see in the industrial field is something which we can call robotic manipulation. Robotic manipulation refers mostly to the way how robots interact with objects around them, so kind of understanding where things are placed, doing path planning, and then performing some actions. And often this comes packed within combining several types of robots with each other. So for example, a platform that is able to move around and a robotic arm that is able to grab things or move things around. And if every module of these robots is independent, you can get very creative in building different types of applications with different robots. For example, in this combination, where you have a platform that can transport all the compartments and a robot arm that can sort and rearrange them. So let's take a closer look at collaborative robots. You can find them in any sizes. Here, for example, are the largest one I saw at Automatica. It's from KUKA and also from Kawasaki. They have robot arms with a span of 3 to 4 meters and which can lift up to 1.5 tons. Also, I was seeing the robots from Istun, and all of them are very impressive because the mechanics to lift and arrange heavy objects is incredible. And on the other hand, you can see robots with a precision repeatability of 0.1 millimeter. That's super precise. And in between the smallest and the largest is a wide range of collaborative robots. And I must say, people get very creative with them. So you can just add different types of fingers to the robot, which can lift packages or which can be attached to some welding machine or some other professional tools, which can then be controlled by the robot very precisely with a very good repeatability. Here, for example, you see the robot of Robotics welding some surface. And this is actually quite cool. So these robots, they have a camera included with which they can get three-dimensional models of objects. And then you can plan a path which the robot should follow in 3D. And then you can add whatever tool you fancy and the robot will follow the path and perform the task which you want it to do. These use cases are all quite industrial. But let's take a look at this use case for directly supporting human, which is a new system called Eden for supporting human with disabilities. But not by just using a joystick, no. They attach sensors to the skin which can detect muscle movement, and based on the muscle movement they can control the robot arm. Or this robot here helping during brain surgeries with the help of laser pulses. How this works, I will tell you another time. And now imagine the robots can not only collaborate with you or the industry, but they can also collaborate with each other by performing more complex tasks one by one or all together. Now we make the transition from collaborative robots to cognitive robots. Robots that can sense or interact with the environment. Here, for example, is the new Neura Sense kit. Do you want to see an example? Robot, check screws. This little add-on basically brings voice control, intelligence and 3D vision to your robot, no matter of which brand. At least this is the claim. Just attach it and you have a cognitive robot. And since we are talking about sensing the environment, let's talk about sensors. Let's start with this completely new type of camera. It's an event-based camera, and instead of a normal camera which captures frames, this camera only captures changing events or changing pixels. Another sensor camera is able to get three-dimensional images, so-called point clouds. So pixels with a third dimension as a distance. Then there is a sensor which is doing laser scanning, and while it is scanning with this line, it reconstructs the object in 3 dimensions. Putting this on a collaborative robot gives the robot an understanding of the 3-dimensional space around and enables it to make very precise movements, like here placing a glass into the right position of the car. Then there was a cool setup by Sensopart, which consists of over 10 sensors. They measure a lot, but just take a look and I will describe it another time. Let's increase the speed a bit and take a look at this setup. Here you have fastly rotating tires, and if we look at this in slow motion, we can see that there is a sensor which can recognize the tires and can make a photo of them. So every time when a tire passes by, a photo can be made, a QR code can be scanned, the position of the tire can be recognized with object recognition, and the tire itself can be classified. Besides this, were way more sensors, and I show you here an overview how they look like and which kind of output they create. But all of these sensors are very interesting, and I will discuss how they are working in the follow-up videos. One topic that we humans understand very well are images. If we want that a robot can recognize images as good as we do, we have to develop software that allows him to perform these tasks. Artificial intelligence helps here with image segmentation models. In this example, the robot can differentiate between floors, carpets, or unknown objects. I spent years on these tasks, and at some point I will also teach them on YouTube. In this example, we can see the model library that robotics is using. And we also see at this image recognition task that AI can fail. It's not perfect. So what can we do to guarantee that no one gets harmed during this process? Right, we take a look at safety aspects. One solution is presented here. There is a setup with a robot on top, and on the bottom is a sensor from this SICK company. And their solution is to have the sensor which can cover a range of 270 degrees. And if something or someone comes too close to the sensors into this red marked area, the robot will get a signal to stop. Once you leave the dark red area, the robot can move again. But if I just elongate my arm and touch the robot, the sensor will never recognize it and the robot will keep moving, which is a potential security risk. But they also have a solution for this with the here presented LiDAR-based detector. This add-on can be connected to any robot arm and it recognizes a human hand or any other non-living object and stops the robot every time when an object comes under the robot arm. This is already a very good start, but it always makes a full stop, no matter what is coming. Another solution is presented by robotics with their omnisensor. Here you can see a setup with a robot arm that in best case always should run with full velocity, but never collide with a person. The omnisensor is placed on top of the robot and scans downward with different types of detectors. And once the sensor recognizes a human coming closer to the robot in the yellow area, the robot will slow down. And once the human comes to the red area, the robot will fully stop. And the coolest thing about it is everything works without AI, which makes it very stable. Today's behind the scenes comes from robotics and NVIDIA. When we in the past trained neural networks with reinforcement learning, we created simulated ideal environments. So everything we simulated there was very precisely defined, and things like light conditions were stable, constant all the time. You don't have this in the reality. In the reality, you have bad lighting conditions, you have unexpected things happening, and quite a lot of also mechanical things that are different to the simulation. So between the simulation and the reality is a gap. And it's a problem, because when you cannot close this gap, you will have problems transferring the simulated neural network into the reality. This gap should be closed with the Neura CHIM, which is a collaboration of NVIDIA and robotics, where they want to build a huge place where people can train their robots with real applications and with real data from these applications, with the hope that together with the simulated data and the real world data, that the gap can be closed and that a neural network can be trained that can understand the real world. Once you have this, you can apply this network on all other robots as well, and they will have the same skills. So this was it. A very compressed version of some of the videos which I have made at the Automatica. If you want to see more, check out the follow-up videos. And if you're interested in the, to my mind, most interesting branch of artificial intelligence, deep reinforcement learning, check out my other videos. There I explain you what it is, how you can program it yourself, and how you can train your own deep reinforcement learning agents. I'm quite sure you will like it as much as I do.